All right, guys, let's get started. As you know, so you guys are section 2. So today we are starting our very first model, right? The regression model. This is like, I would say, the starting point of everything that we've done. So before it was just the basics. We were just, playing with tensors, kind of getting a view of how everything works. And now we're going to start focusing on building specific algorithms, right? So the first one that we will look is regression. Okay, so that kind of makes a lot of sense to start there. And so we'll start building up our code. This, of course, takes a lot of time. The great thing about this is a lot of the code that we're going to build now we'll continue to use throughout the semester, right? Obviously, things get more complex in the inference functions because we're doing different things, but a lot of the things will be similar. Okay, so I've been thinking about which data set to use, and we'll probably use the wine data that I posted initially. We'll start playing with that. Okay, so if you remember, there's a regression wine data. We'll use that, and then from there we'll look at other things as well. Okay, so remember, so the goal of this problem is regression. So we're going to start with the the wine data. Okay, so let me go ahead and start our Jupyter notebook. So everything should be recording now. Yeah, so we are recording. Okay, so let's start our Jupyter notebook. ITS 520 all, and you guys for section 2. Okay. And let's actually create a folder for this. I'm just going to call it regression. So I'm going to take a very object-oriented approach for this. And it's just because, that's kind of how you should do things. A lot of what we implement will use classes and instantiating objects, basically. So let me set up here. I'm going to call it regression. Okay. Now there is, in the theory, there's linear regression and nonlinear regression. So to us, it's just, notice I'm not, if you've taken a stats course, maybe they called it linear regression or something like that. Notice I'm not calling it linear regression. I'm just calling it regression. That implies it could be linear, nonlinear, all kinds of things. In fact, we will not just look at neural nets. We will look at other things. All this, we have a few other solutions such as regression trees. Okay, so we'll take a peek at that as well. All right, so I've created the regression folder there. I'm gonna move the data. So I just need the wine quality data set. I'm gonna start with that, and then we'll use something else possibly. I'm gonna move that in here. I'm gonna create a folder called data. I'm gonna add the wine data in there. Okay, so there it is. So now let's go ahead and start our environment. So conda environment list. It should be section 2. So I'm going to do conda activate I37 underscore ITS 520 and 2. You guys heard number 2. Okay. So now let's start the Jupyter Notebook. Oh, let me make sure I'm in the correct place. So DIR. I'm going to go into regression. Okay. DIR. Okay, there's my data. My data set is in there. And now I'm just going to create my Jupyter Notebooks. Okay. So let's start with Jupyter Notebook. Right, so now let's start a Jupyter Notebook. And I'm just going to call this PyTorch regression, basically. So I'm going to rename it. Now we're going to do several things. So this is more like a problem, right? So if you had some regression data, how would you analyze it? Obviously, what we want to do is predict. We're going to deploy this solution. So we'll go as far as using the Onyx framework. So if you remember, we're going to deploy these on GitHub. We're not going to get to that today. This should take a while. Okay, so it's not because we're going to build it from scratch. I haven't even posted this notebook on the course repo yet, but I will be posting it as we finish. Okay, I just have it somewhere else. All right, so I'm going to rename it. Let's call it regression with PyTorch. PyTorch. Okay, so what are the things that we need? So I'm gonna just kind of, let's say we're tackling this problem, right? So what are the things that we would need? So we need the libraries, okay? So libraries. Okay, that's kind of one of the first things we would do. So I'm filling in some of the sections, right? We would need the libraries. These are the imports, etc. So just to give you an idea, import NumPy as MP. Okay. See that? So something like that. What else do we need? Somewhere along here, we need to read in the data. So we're going to say read the data. For this one, I'm going to use pandas this time around. Okay, much more like powerful professional way of reading in your data and playing with it. Okay, so read data, let's say. Mark down. Okay. Then when you get data, you want to do a little bit of like data analysis, right? So you want to analyze things. So I'm going to say data analysis. Okay, we're going to do a little bit of that. And that can be things such as correlation coefficients, correlation matrices, feature ranking, etc. So let's just say for now, correlation matrix. Okay, so we'll do that. Should not be that difficult to do. Okay, so that's one of the things. Then after that, obviously, we want to build a model. So build a model, and this is where we're going to start getting into linear regression, nonlinear regression, neural networks, etc. Right? So we should be able to implement, this with a neural network. So build model. Okay, and so that's going to be like that. Build model. Then after we build a model, we evaluate the model, right? So let's say evaluate the model. So that's where we know train, test, split comes in. So evaluate model. Okay. Yeah. And so let's run that. And then finally, we're going to deploy the model. And that's going to be, you're going to create a website. So that in itself is a little bit involved. It's good to know a little bit of JavaScript there. Okay, so we're going to say deploy model. So in this case, we will be using something that works well with PyTorch. It's a framework called Onyx. There's a couple of ways of doing that. There's Onyx, and then there's Onyx Runtime. So I believe I have examples for both. This is Onyx, and also the place to deploy is GitHub. So we will be able to run our models from there with GitHub pages. All right, so, and that's it. So that's kind of the logic, okay? And now we just have to fill in. So this is usually how you attack a lot of problems. Obviously, you could do this for, you know, CNNs, transformers, etc. Just that, you know, a transformer model may be much, much larger, right? And for instance, GitHub only allows you to load files up to 25 megabytes. I think if you have the paid service, it's like 100 megabytes, but it's still pretty limited. All right, but for this, it doesn't matter. I mean, you know, because it's going to be smaller than 25 megabytes. Obviously, you could break sometimes the model, but that's just might make it slower. All right, so anyway, so this is the, you know, this is the basic template that we're going to follow, okay? So the very first thing we want to do, you know, is get the data, right? Read the data in. So that's kind of the first step, if you will. We're going to need Torch, obviously. So we want to add a few libraries in here. So import NumPy as an MP, import Torch. We will need to install a few things. Also, I think we've never used pandas. Right, so that might break. So if I run that, still thinking. And then I will be adding a few things as I need them. Okay, so we'll come back to this part. All right, so I guess it has pandas. So maybe when we installed it installed it automatically. All right, so that's good. Let's now, guys, any questions? So let's now start with the very first part, which is we want to be able to read in our data. Okay. So I'll go over here. Okay, so we're gonna read our data. Oh, here, down here. So we should be able, since we created pandas as PD, pandas has a, so let's call this wine raw data, right? Something like that. So we're gonna think about loading our data into this variable. So you can type pd.read underscore CSV. Okay. So I have two data sets, but let's try the wine data set first. Okay. So we need to provide the file name for this, which will be what? Let's actually create a path for that. Path data. It'll be data. And then what was the name of it? We have to go over here. We can click on this one. So it's called wine quality -white CSV. Wine quality -white CSV. Okay, so that's our file. And then we can provide in the function, the path. So we're just going to say path data. Okay, guys. So go ahead and run that one. Okay, good. So it seems to have done it. Now let's go ahead and if we just, because we're using a Jupyter notebook, we can sometimes just visualize the data directly. So we can type, let me actually change this name just to all uppercase. All right, so wine raw data. Okay, so let me run it again. Okay, and okay, so it's giving me, it doesn't like the fact, the delimiter, right? It's probably the delimiter that's giving me an issue there. Okay. It uses comma by default, I think. Did you try it?
Yeah, it worked.
It worked.
We learned that from last class.
Yeah. Just double checking that I got the right. It's a separator
I used the delimiter.
and it took it?
Yep.
Okay. Did it work? Hmm? Oh, that's right. That's right. That's right. Wow, there we go. Nice. Thank you. Perfect. All right. So yeah, good. So actually that's so great about these models, right? That they, in the other approach, we use delimiter, and then here is also consistent. All right, that should be all that we need. If you notice with this one, in the example we did, I think last week, we were losing, we had to get rid of the headings, right? But here we don't have to get rid of the headings. We can keep it and actually use it, much like you would do this like in SQL or Excel even, right? To manipulate things. So here we have our data. Notice it doesn't show everything, but it shows us some things. So we know we've got 4,898 rows, 12 columns. All right, and we know we've got our values here. We can see them. And so what we're going to try to build is a regression model that predicts these values. Okay, so given these inputs, now that's a lot of inputs, 11, and predict one input. And we're going to build a model, deploy the model, measure performance, etc. Okay, any questions so far, guys? Questions? All right, good. So we've got our pandas data frame. Okay. So now we can we have to think of a way to view the columns. So let's see if we can't do that. So let's add a cell here. And we're gonna create a variable. And let's just call it headers list. And you'll see why this is important in a second. So from our variable, I'm just gonna copy it, wine raw data, which is a pandas data frame. Okay, because we read it in pandas, it is a data frame in the language of pandas. So it's a special kind of object that has properties. So we should be able, actually, before we assign it to headers list, let's just look at some of the options. All right, so I'm going to do dot columns, right? So that's the first thing that I want. So this should be an object. You can see it there. It basically has it's an object, right? And it has the column names: fixed acidity, volatile acidity, citric acid, residual sugar, chlorides, and so on. So if you were doing this kind of study, you would start to get really interested in knowing things about this, right? So about the chemistry, I guess. This is maybe chemistry or food science. And you would be like, okay, what are the factors that are very helpful in detecting the quality? You know, which factors correlate more strongly with the quality? Are there any that correlate? Oh, yeah. The file? Oh, where did we define it? Yes, I defined it here when I read from the read CSV. I read it into that. It's the variable that holds the pandas data frame that holds the data. Got it? Any other questions, guys?
Does that variable then become the pandas data frame?
That is the pandas data frame,
Awesome.
in fact. So what PD read CSV does is it takes the CSV and it creates a pandas data frame. And now it is in here. So you could, some people actually do this to indicate, to remind themselves that it's a data frame. That's a thing that you can do to help yourself. I just didn't do it, but it's definitely not a bad approach. Got it? Now remember, pandas is extremely powerful. We're not going to look at everything that pandas does. We could spend a whole semester just on pandas. Okay, it's very powerful. Anyway, so I've done this, right? And now I created an object of the parameters, the column names. Now, this object can be broken down into like the values. So I can do values. And you can see now it's changed a little bit, right? And I can even go as far as converting this into an actual list in Python, which is probably what we will want to do. So I'm going to do dot to list. And that, like I said, the idea is that since you're doing regression, before we actually build a model and everything, we just want to know a few things about, you know, the relationship, the correlation between quality, which is the thing we're trying to predict, and the inputs to this model. Okay, now that I've shown you how it works, I'm going to go ahead and assign it to the list, and that way we can just use it as we move forward. Okay, so make sure you do that. Notice it's there. So now you can print it out if you'd like. Just to view it, just print out headers list. Okay, so you can do that. All right, and we have it right there. Okay, so that's our first approach. So we've got the list of these things, right? Now, what we want to do is we want to do a print the correlation coefficient, right? So we're going to print the correlation coefficient matrix. So let's do that. Let me just find it here. Okay. Okay, so this is going to involve using NumPy. We're also going to use matplotlib, and we're going to use something called a heat map. So we're going to need to import. Oh, and we also want to use it to use so there's a couple of ways to print out data, right? There's a library called MLX10, which we're going to try. So we may need to install that one. Let's go back here and let's do from MLX extend dot plotting import heat map. Okay. So if I run this, yeah, it doesn't know MLX extend. So let's see if I can install it. All right. All right, good. So we did that, so let's comment it out. Now let's try it. Now it's better to do this as a function, okay? So that's probably a good idea to eventually build a lot of this code as functions, but I'll just kind of do it, kind of do it here. All right, so we need to build this, okay? So we're gonna create an object called, so this should be, all right, so the pandas data frame is this, right? And we are going to select all the variables that we want to display in the correlation coefficient, okay? So that's what I'm about to do. So it's a little bit strange how that might work. Now, these are in header list. So what I'm gonna do is I'm gonna create an object called CM. I'm gonna use NumPy, NP correlation coefficient. Let me see if I spell that correct. Or coefficient, okay? And so that's the object, and I need to provide to it the data, right? So the thing that we want to see is the data in the pandas data frame. Does that make sense? So that's what I'm gonna give it now. So that the name for that was wine raw data, right? Should be. So wine raw data dot values values. Okay, so let's try that. And then let's just do PLT show. Let's just see. And I haven't created this, so I need matplot for that, right? So let's do import matplot live dot pyplot as PLT. Okay, everyone with me? So I'm building it with several things. But it should work. So this is, yeah, so this should work. Okay, all right, so let's just try this for now. Let's see what happens. So we start at the beginning. Run. Read the data in. Data's there. Got my list. Okay, so this is the part. See if it breaks. Let's try. Maybe there's no data in there. Okay, so let's go into pandas and tell it what we want, I guess. So I'm gonna give it headers list. Okay, let's try it again. Okay, so I guess let me try adding this next part. HM equal heat map. And heat map will take CM. All right, so let's try that. So notice this CM goes in here. Okay, a little bit better, right? Making some progress. Doesn't look great yet. We'll think about that one, but a little bit, right? Everyone with me, guys? All right, so this is the nature of sometimes working with these frameworks, right? You got to bring in a lot of things to make something happen. Couple of things. So let me get rid of this. I'm just curious if by default it just grabs every. Yeah, so it does work. This is what I thought. Now, why is it useful to put in the square brackets the list of headers list? Headers list is all these variables. Do you guys see that? So why could it be useful to do that? Because you may not want to show all variables. Do you guys see what I'm saying? And so just before in this class, you've learned that you always index by number, right? You spent a lot of like time on indexing by number, 3, 4, or slicing. Pandas, however, because it's powerful and more user-friendly, I suppose, allows you to index by the name of the column itself. So that can be intuitive and useful. Okay, so let's try this example. I think it's charging. Yeah, it's charging. All right. Okay, so as I was saying, let's go back to the code. So let's say that we don't want to view all of them, right? And we just want to view a few of them, right? You just want to see the correlation between certain variables and other variables. Then one thing we could do is we're going to add a new cell here, and I'm going to create header list 2. Okay. And I'm just going to copy I'm going to create a list, and I'm just going to copy like the last 5, let's say. Do you see that? So I just created this list of these 5, and then I'm going to replace this with 2. And so the idea would be that now it's going to use just that list. And do you notice that the correlation coefficient became smaller, right? It's, more, it's easier to view, but also you can just focus on the things that maybe you're writing a report or a paper or something, and this is what you want to talk about. So you would select which columns to view. Does that make sense, guys? Everyone with me? Now we can continue to make this a little bit better. Okay. So let me try just for a sec. I'm gonna ignore the 2. Whoops, just go back to the original one. I guess I'm gonna stop it. And I'm gonna add that dot T. Meanwhile. All right, let me refresh the kernel here. Okay. Okay, let's go back to the beginning, run everything. So run the libraries, heat map. Okay. Okay, we've got our pandas data frame. We've got the headers list, all headers now. Okay, hit run. We can ignore headers list 2. And hopefully this will, okay, there it is. So we're back. We generated the figure. Okay. Let's try making the figure a little bit bigger. See if that helps. So we also want to provide column names and row names, right? So that might be useful. Now in a correlation coefficient, basically we're comparing all of these to all. Oh yeah, I'm sorry. So that's what I'm going to show you, but it's basically these variables are here and here. So I'm comparing to each other. So there will be a diagonal, for instance, where they're the same. And it just means the relationship with them, between them. Yeah, so it's going to be, so this list, right? So since I'm using the original list, you can imagine that I'm about to show you that, but every row is one of those compared to every column, basically, which is the same. Yes, comparing against each other. So for instance, if this said ABC, then this would say ABC. And when it's B to B, it's like a one correlation because it's the exact same thing. But we're about to see that. And what this is telling me is, if you notice, the scale goes from -1 to +1. You see that? So if you have a 0, it's a good question. If you have a 0, what does that mean between two variables? There's no correlation. It's 0. The 0 indicates that there's no correlation. If it's a 1, it means that there's a positive correlation, is the maximum. They're like very correlated. And if there's a -1, they're still very correlated, but just inversely. And that doesn't mean that that's not a good thing. It's good to have that correlation too, just they're inverse. As one goes up, the other one goes down. That's all it means. Got it? All right, so, but that's what we're gonna do. So we're gonna add row names and column names to this example. Okay, guys? So let's do, and then we're gonna try to make the figure a little bit bigger too. So we can do that in heat map. So row names, okay, row names equal the list, right? So it should be headers list, I think. Yeah, headers list. Got it? And then on the column side is pretty much the same list. So we're going to say column names. Yeah. And that's going to be equal to also headers list. And since we're here, let's just try different figure sizes, see if that helps us, because the readability is not great in this one, right? So I'm sure there's more functionality for this that you guys can play with. Let's try like 20, 10. All right, so we're gonna run this again. Okay, so I'm gonna hit this, I'm gonna hit run. All right, does it look a little bit better? It looks better, right, guys? It's you know, it's bigger now. The visualization here is better, and we've got names. So just this is, you know, like if you want to do data science and you're given this project, just this alone, do some data science, right? So what can you tell me about the data now? You can actually say things about what you're seeing. So obviously, if you notice, if it's fixed acidity and its fixed acidity is a 1 because they're the same thing. So obviously they're correlated. Now remember that these values are gotten from the data itself. So remember that to np.correlation coefficient, we gave it wine raw data. That is the pandas data frame that holds all the data. Does that make sense? And then we just, if we don't provide this list, it just takes all values, but I just showed you that if you do this, you can select just a few variables, like saying headers list 2, and then it doesn't show all of them. Okay. So what would you say about the results that you see here? What would be your conclusion? Now, quality is the variable in question, right? And you're comparing quality to what? To all the other variables. So you can look at this column, the quality column, right? And compare it to chlorides, fixed acidity. So what would you say? Let me ask you this question. What would you say about citric acid in relation to quality? Inversely, because it's negative, but look at the value.
They're less than 1. So they might not be.
It's 0.01, right? So it's very small. It's almost zero, basically. So you could argue that there's no correlation, right? How about what variable would you say is the most important possibly in quality? Alcohol, right? Alcohol. 0.44. So that determines the quality. So people don't care about anything except the amount of alcohol, right? And then the second one would be what? Now, alcohol also is directly proportional or correlated, right? Now, what's the next one? Sulfates. I think it's density, yeah. Sulfates is 0.05. It's actually pretty close to 0.
Oh.
Yeah, so
So we saw that.
yeah, so it's 0.05, so it's almost 0. Whereas density 0.31 negative, inversely proportional, right? Huh? pH is 10. Yeah, because it's not really whether it's negative or positive. Remember, negative is also good. It just means that they have, like, as one goes down, the other one goes up, but it's still a good factor in determining. So this can happen like if you're trying to determine the temperature of a furnace, right? Well, you can throw in a lot of natural gas and that brings it up, but also throwing in a lot of ice brings it, controls the temperature, even though it does it in a different direction. It is still important for that. Do you guys see that? So yeah, and also you can do this analysis between variables too, right? How do they relate? How to within the data, you can do other things, right? So, pH and is highly correlated to what? To fixed acidity. Yeah. So that's highly correlated. There's one here I saw that was really high value. Which one? Alcohol and density. So density and alcohol. It's minus 78, right? Yeah, so that there's a high density. Because at the end of the day, we are predicting quality, but we could choose to predict something else. Who knows, right? So we could choose that we want to predict alcohol, for instance, given the variables. This is just the data set that we have, right? And it's the reality of it. Got it, guys? Yeah. All right, great. So this is one of the things that we can do. This is a very important thing if you're looking at regression type of problems, and you do the analysis of, this is called the correlation matrix. So the correlations analysis. Notice that we haven't built any models. This is completely independent of a model, basically. Later on, we can also do things like feature ranking, and we'll explore that later, okay? But for now, I'm just kind of trying to follow like a logical flow, like for data science, of what you would want to do. So at this point, you kind of have, a sense of how to, the relation between the variables. That alcohol is really important. So if there's no way that you can collect all these variables because maybe it's very expensive, it might be a good idea to make sure that you get alcohol, but you could possibly skip free sulfur dioxide and citric acid, because these may all be like lab tests that you have to conduct, that may be expensive, and so you can just like skip it in the future. Got it? So it gives you a really actionable thing to do. All right, so now that we've built this correlation coefficient, we've done a little bit of analysis. So I'm not sure if I put this in analysis actually. Okay, I put this in read data, and I think I wanted it in data analysis, so I made that mistake. So let's just move this part down. Can just run this cell and get rid of that. Probably don't need so many of these. You can cut out a few and then just put it in data analysis. There you go. Hit run. And there we have our graph. These are very nice. I think you can right click and save image as, so that's something that you can do. You can also sometimes, I'm sure there's a function to save it to a file from here. And that way you can add these to your reports, etc. All right, now what we have to do now is we're going to start the process of creating X and Y, right? So if you guys remember, we want to split our data. We're going to convert it into PyTorch, all that stuff. Okay, so that's the next part. And then we will basically have the X and the Y, maybe the X train, Y train, and so on. And then we can start building our machine learning models. Okay, so to do this, let's say, now we'll be using all the variables, but we could also choose just a few. Okay, so currently this is a pandas data frame. We need to find a way to convert a pandas data frame into NumPy or Torch. Okay. So let's go ahead and do that. So we're gonna do that, I guess. Now we can do read data. So actually, let me add a section here. Let's just call it process data. Okay. All right, so the first thing is we're going to convert the pandas. Pandas will not fit into a torch model. So let's just grab the pandas data frame. And we're going to try to convert it into NumPy. We're going to add a comment here. NumPy. All right, so that should be wine raw data. But now I'm going to give it this because it's going to start getting confusing, right? So what is what? So I'm going to just give it underscore NP to indicate that I'm making it into a NumPy. So then Control V for wine raw data. That's the original pandas data frame. And I'm going to do to NumPy. Okay, so that should be it to NumPy. All right, so now we have it in NumPy, hopefully. So we want to probably corroborate that. So we're going to print it out just to view. Okay, so. All right, and it does look like a NumPy array, correct? It does look like a NumPy array. Another thing you want to do, obviously, here is look at the shapes. So we're going to say dot shape, and we want to print out the dimensions of it. All right, and as we can see, it's got the 4,898 rows and the 12 basically columns. Yes, exactly. All right, so now we need to do a couple of things. We need the X and the Y. Right, so how do, so we're gonna generate the X and the Y from the NumPy, right? That's something we can do. So we've converted pandas to NumPy. Now generate X and Y. Now here we could do it for selected indices. But you guys, I mean, you guys should know how to slice by now, so let's just do it for all. Okay, so what do I mean by this? I mean, let's get the X and the Y, right? Okay. So we're gonna take this one, right? Everyone with me? So you know what we need to do. So how do we get the X and the Y?
Categories for X, right?
I need to take the NP wine data, the NumPy one data, and now convert it into the X and the Y.
Okay.
Yeah. So how do I do it?
Oh, you do like the negative one thing.
Okay, yeah. Well, tell me though, that's what that's what I'm asking. So I need to slice. So how many rows do we slice? All of them, right? So that's colon, right? Comma, and then zero. You could start at 0 if you'd like, and then colon, and then -1. Okay. Yeah, everyone with me? And then what about for the Y?
That last, just look at the last one.
Yes.
If it is
Yeah.
quality or not.
Yep. Colon, comma, -1. Yep. That's right. Oh, I'm sorry. Yeah. -1. Got it? So this is one way of doing it. Another way of doing this is actually picking, let's say that I wanted you to, we're gonna keep it like this, but this is just an example. Let's say that I just wanted you to use the first 3 variables, right? And then the last 2 will be outputs. How would you do that? Just as an example. So the first 3 variables, right? So that would be 0, 1, 2. Does this make sense? You're just selecting the first 3 columns, and then for the outputs, you're just going to select the last 2. So that would be, you could do -1, -2, right? You could do that. I think I added 2. An extra there. And it does it automatically. Do you guys see that? We can do that, okay? That's something keep in mind, because in another data set that I will give you, I may give you multiple inputs and multiple outputs, okay? For the regression model, like predicting quality, but also predicting price or something, 3 things. So just remember this. I may just want, given 5 inputs, predict 3 outputs. But currently we're doing 11 inputs, 1 output. Okay, that's important as we build the neural networks and stuff, right? Because the dimensions are extremely important. So I'm just showing you how you could do this. But for now, let's just exactly as you guys have done it. We can keep it that way. Okay. All right. So now, of course, once you do this, you want to print out the shapes once again. Just to corroborate. So I'm going to run this one. Oh, did I remove a bracket? And let's print out the shapes. So I'm gonna do print x dot shape, and I'm gonna do print y dot shape. Okay. So if you notice, it's 4898, comma 11, and then 4898, and just 4898. Now, now this presents that scenario where we may need to make this 4898, comma 1. Okay. Let's wait and see what the neural network tells us. Okay, as because we're still in NumPy and we're gonna convert to Torch now, right? So that should be the next step. Everyone with me? And we also have to split the data also. Okay, so it might make sense to split the data. So this is another thing that you could do this in Torch, or you could do this in Pandas, but the way I'm doing it is, if you notice, it's like I do most everything in NumPy, right? You know, because that's kind of what I'm more, or I remember mostly, or I take advantage of sklearn whenever I can, you know, things like that. So that's why I'm making the decisions that I'm making. Okay. All right. So the next step in this process, we have generated X and Y. We've got those available. We've printed the shapes of them. And I don't like that we don't have the. How would we make 4898, comma 1? Unsqueeze it. Can you guys give me the command for that? Let's just kind of add a cell here so that we can take it out if we don't need it, but let's just have it conveniently just in case, right? So how do I do it? Come on, tell me. Would it be y equal something? Oh, not Torch yet. We got to do it in NumPy. NP dot unsqueeze. And then? Maybe. NP unsqueeze. I don't remember what it was. Maybe y, comma, and then it would be 1, right? You're saying. Yeah. So let's try it. That's no, did I misspell it or something? I mean, I don't remember off the top of it. So it's not there, right?
Negative one colon. And that's the same thing.
Negative 1 colon.
When you do y equals.
Oh, okay. So negative 1 colon.
Yeah.
Oh, yeah? Really? Okay. That's cool. Let's try that.
I put 11 total on mine and it gives you the 1.
Yeah.
Oh, there it is. Yeah. Huh. So you put the index 12.
I do 11 colon 12.
Oh, 11 colon. Okay. Yeah, I like that approach. Like this?
Yeah.
All right. Yeah. Okay. All right. And you're sure that's let's actually print y. Yeah, it is the last column, right? All right, so we're good. So I like this. Okay. Unsqueeze would have been like something, but I don't remember the NumPy version of it. But now it looks a little bit better, right? This is kind of what we want, the 4898, comma 11, the 4898, 1. Everyone with me? And we are in NumPy. So now, what do we need to do? We need to, we want to split the data into train and test. Okay, so we're going to do that with sklearn probably. So then we need train test split. All right, so I don't know that we've installed sklearn actually. So let's see if we have it. Import sklearn. Okay. All right, so apparently it's there, so that's good. Then let's say from sklearn, from sklearn dot model, oops, dot model selection import train test split. You guys see that? This is just like a lot of people just use this function for doing the train test split. There may be other ways of doing this. There's your own code even. You can do this manually, but it's just kind of like, you'll see this a lot. I do it this way. All right, everyone with me? So let's go ahead and run this one to make sure it's got it. All right, so that's available. So now we can go, let's actually save. Let's make sure we save. I'll post this code later, but yeah, save. All right, so now we're going to take X and Y and we're going to try to split it basically, because remember that we're going to do training of the model and then we're going to test the model on the test set. And it should never see the test set, okay? So we're going to create 4 variables, X train, X test, Y train, Y test. You basically write them in this order. So X train. Notice that I'm using X uppercase for X's and lowercase for Y's. X train, X test, Y train, and Y test. This is the way that train test split will return the values, okay? So now we invoke the function train test split, okay? Now keep in mind, in a lot of things that we do, we're always going to do similar things, right? We're always going to be doing similar things. So what do we need to provide? We're going to provide comma X and Y, which we have above. And then we're going to provide also the test size, which usually should be for this data set. It's got 4,000 samples, so I think like 20% should be good. Okay, so I think it's 0.20, right? 0.20 like that. Okay, yeah. Yeah, just 0.2. Now, another thing you may want to provide is the random state, comma. So a lot of people just do this 42, right? And then that way, whenever you type that, you always get the same randomization, okay? Make sense? But later on, we're going to learn that there is there's split like this when you do 20% split, and there's also something tenfold cross validation, which basically means that you divide the data into like 10 bins, and then you're going to train with 9 of those bins and test on 1, and you repeat that 10 times, and every time you're like rotating. So that is a lot of code to do, okay? However, there's a trick which I kind of sometimes call like the poor man's test-fold cross validation, which is simpler, and that is that you can just simply, every time you run through your code, change the seed. You see that? So you're as you're doing your analysis, you're no doubt you're going to run your code several times, and so it kind of makes sense not to do, even though you see this all the time, don't do that. Instead, just kind of change the seed every time, and that way your results are changing a little bit. And it's like a tenfold, just if you do it 10 times, it's like tenfold cross validation. Do you guys see that? But without having to write tons of crazy code. is my point. So to do that, yeah, we can just do that manually. So we probably need random for this. So we might need to import another library and just do import random. Here, so this should be at default. So I don't believe we need to install. Yeah, so it's available. So in here, for random state, we're actually going to create a variable then. Okay, let's call it random seed. That's a good name. Random seed. And instead of 42, it'll be a random seed. Now, if you want to go back to 42, you just do that, right? And you just, or any value that you want. But for now, comment it out and instead generate that number every time. And that way your values are changing a little bit. So in this case, you just call random.random. And this will give you a value between a decimal value between 0 and 1, I believe. So then you can just simply multiply it times 100 or 1,000, and that's going to give you more random values. You see, so it's not always 42. Again, the idea being that the distribution of what goes into train and what goes into test is changing constantly, and that may be useful to see your model change. Okay. So in a perfect world, even though the values are changing, your performance is always like revolving. If it's like 78, sometimes it's as low as 76, sometimes it's as high as 82, but it's still within that specific range. And that's really what matters. All right. And then this value, you need to make it integer. Otherwise, I think it'll break. So just make int. And that should be it. Okay, so that's kind of a quick way to do tenfold cross validation, and you just assign random seed. So at this point, I ran it. So that tells me that I probably now have my 4 variables. So once again, I need to print out the shapes, because you always want to check those things. Okay, so I'm going to do print xtrain dot shape, and then I'm going to do print xtest dot shape. Then you want to do print ytrain dot shape. And finally, you want to do print ytest dot shape. Okay, hit run. And you should always be getting something like this. So 3,918 samples is what will be used for training. 980 will be used for testing. Yes. And those are the X values, right? And then on the Y vector, again, you have the corresponding 3,918 and last column, or 980 in the last column. These are aligned, okay? So that's really important to think. Like the third row of this one corresponds to the third row of this one. That's the regression value that's associated with the 11 features. Got it, guys? Any questions so far? These are the steps, right? So a lot of the things we've seen already individually, now you're just using them in a sequence. Okay, so now I believe we are ready to convert to Torch, which is what we need in order to start building our Torch models, okay? So that should be the next step. Yeah, so we are now going to convert to Torch because this is a NumPy array. I've used NumPy, I used sklearn, I used everything. Now I'm just going to make it into a Torch tensor. And so to do that, and you guys already know how to do this, I believe. So I'm going to create down here. I'm gonna do X train. Notice I'm gonna use the convention of using the underscore TR to indicate what everything is, okay? So this should be X train underscore TR, right? That means torch. And then I'm gonna have an X test underscore TR. Okay, and I'm also going to have a Y train TR. And finally, I'm going to have a Y test TR. I like to do this for some reason. All right. All right. So I've got my 4 variables that are going to be torch tensors. So how do I do it? We saw in the previous classes that we can just invoke torch dot, and then what was the function? From NumPy, right? Very good. So we can use from NumPy. All right. And now we feed in X train in here. We repeat the same. So I can probably just copy this. Okay. And let's go here. So if this is X test, so it should be X test. And this one should be Y train. And this one should be Y test. And now they are torch tensors, basically. Got it? Any questions? Let's do one thing. Before, so I haven't converted it, but you know, that converts it, right? Let's try something. How can I view the type of a NumPy array? Can I view the data type? You guys know? Just type?
Yeah, type and type.
Alright. Let's try. Just like type like that? So it just gives me that, right? So I wanted to know, like, if it's a float, you know, or what type of a float it is. So that to be more
Can
specific.
you give it just like an index of the matrix then?
I wonder if it's dot type.
If you
I
can-
know this was in huh?
Mm.
D type, dot D type?
Yeah.
Okay. Let's try this. Yeah. Float 64. You see that? Float 64. For some reason, Torch gives you trouble with this sometimes. Okay, it's just like a thing that we will encounter. I even encourage you, I'm going to give you the fix, but I encourage you to just keep it as a comment. Okay, run your code with it, and then if it breaks, go back and fix it. Okay, guys? But the issue is that Torch, there's a few weird things with Torch that you encounter from time to time. And this is one that I encounter sometimes, like the data type. It doesn't like float 64 for whatever reason. All right, and so to fix it, what we can do is just set it to float 32. Okay, that should be more than enough data. Okay, and so it's just maybe it's just a thing that is trying to conserve memory, and that's why it's erroring out. But let's just fix it. We can fix it at the NumPy level. Okay, so we don't have to fix it at the torch level. Okay, so that just means let's do it here. So I'm gonna even add a comment here, and I'm just gonna say something. Fix in case float 64 error, okay? So I'm just gonna add that in there. Markdown, run. Okay, so to fix it, we should be able to, and actually I'm gonna write fix data type. Okay, so it should be just X train and then X train. And here you're gonna say dot as type, and you're just gonna change it to float 32. So you can do that by saying np dot float 32. Because even though we're doing this in NumPy, the error happens when you start building the torch graph and running it, okay? So this, I'm gonna leave it uncommented, but I encourage you guys to put a comment so that you can experience the error and then maybe, fix it. All right, so let's do it for all four. So X test, and then we'll take the 10-minute break after this, and then we'll pick up where we left off. I think we're almost ready actually to start building the architecture of our neural nets and everything, right? So we're gonna build several architectures. So X test will be X test dot as type. As type. Yeah. NP dot float 32. Okay, so we're making it float 32. Also do it for Y train. Y train dot as type. And then again, NP dot float 32. And finally, Y test Y test dot as type NP dot float 32. All right, so usually that fixes everything, in my experience at least. So now you want to run these in sequence, obviously. So you're gonna take it from float 64 to float 32. You can print out the same thing that we did here and corroborate that they are float 32, hopefully. And then now make sure you convert them into torch tensors. Okay, so they are now torch tensors. And so we're starting to get into our model. Okay, all right, so let's it's 6:23, so let's take a 10-minute break. We will come back at 6:33 to continue with this approach. Hopefully we will build at least one model today, and then we can add other architectures next time we meet. But I'm thinking the way progress we made today, we may do this by next Wednesday. Yeah, I think. And that's your first model, regression. All right, yeah, so let's take a 10-minute break, come back at 6:33.
So
Yeah.
NumPy doesn't offer unsqueeze, only squeeze, so you have to do it in a torch tensor to unsqueeze.
But I'm sure you can unsqueeze it in NumPy. There's dims and other stuff.
Yeah, there might be some way, but
Yeah.
just the function unsqueeze.
Yeah. They're inconsistent sometimes.
I was just saying, on the NumPy calculation, the unsqueeze function doesn't exist, only for the torch tensor. But it has squeeze, but not unsqueeze. So since there are so many functions that are the same that they both have, like.
I need to pause this thing.
Like all, so it's got squeeze, right? but does not have